Hi, everybody. Mary here, and this time we are actually going to spend some time translating from a statement, from a English language statement into a chemical equation. Last time we talked about all the things we have to keep in mind when we do that. Now we're going to practice. So here goes. A strip of magnesium metal is burned in the air to produce magnesium oxide. So let's write a chemical equation to represent that statement. So a strip of magnesium metal, the symbol for magnesium is Mg. And we have to put the state of matter. How do we determine that? That's why we look at our periodic table. At room temperature, magnesium is a solid, so we put a little S for solid. Is burned in the air. Well, to burn means to chemically react with oxygen, so plus oxygen. And oxygen is one of these naturally occurring diatomics. So when we have oxygen alone in a chemical reaction, it is always O2, and you and I know the air happens to be a gas. Ain't that spiffy? And it produces or yields magnesium oxide. How do we know the equation for magnesium oxide? Well, we look at this equation, magnesium oxide, we look at the two reactants. Magnesium is a metal from this side of the periodic table. Oxygen is a nonmetal from the right side of the periodic table. So we know that this compound is ionically bonded, and we look at the most common ions. Now, you do not do your bonding in the chemical equation. You do it below, above, off to the side someplace. The most common ion for magnesium is +2. The most common ion produced by oxygen is -2. And if you forget which one comes first, the nice thing about having the name in front of you, it tells you magnesium comes before oxygen. If we look back at our rules for ionic bonding, if you've got the same charge on both, nature is going to produce a compound with a net charge of 0. So that means we're going to have one of each, and the chemical formula is going to be magnesium oxide. If you also recall when we talked about ionically bonded compounds tend to be solids at room temperature. They have very crazy high melting points, so they are solids. And that is our chemical equation for this statement. Magnesium solid reacts with oxygen gas to yield magnesium oxide solid. Now, some of you who have had some chemistry in the past may look at this and say, Mary, it is not a balanced chemical reaction. We're going to come back and balance all of these in the next talk. But let's write some more reactions right now. The next one, we have a piece of pure sodium metal reacts with chlorine gas to produce sodium chloride. Now, I'm going to go ahead and do this, but if you're feeling confident, hit pause, try it, and then follow along to double check that you did it right. Okay, sodium metal. Sodium is right here on the periodic table, so the color is an indicator of its state. Sodium is a solid at room temperature. Reacts with chlorine gas. Chlorine is one of those diatomics. So chlorine, Cl2, and it tells us it is a gas. If we didn't know that, if we were not told it's a gas, the color on the periodic table indicates it is a gas at room temperature. And it's producing sodium chloride. Now, sodium chloride is a common compound. We've worked with it a lot in the class. If you did not know its formula, you could say, aha, group 1, sodium, ion of +1. Chlorine is a halogen, ion of -1. We have one of each, and so the compound is NaCl. And we know ionically bonded compounds tend to be solids at room temperature. And that is our complete ionic that's our complete ionic formula, but this is our complete chemical reaction. Okay, my friends. Nitrogen and hydrogen gases react to form nitrogen trihydride gas, also known as ammonia gas. Hit pause, give it a try, and as I've said many times, watching somebody do something doesn't mean you know how to do it on your own. So hit pause, give it a try, and then we'll go through it together. Okay, nitrogen and hydrogen gases. So nitrogen gas. Why is this an N2? Because nitrogen is one of those diatomics. Where are you, nitrogen? There you are. hydrogen gas, H2 gas. Again, it's one of the dirty seven, the diatomics. React gives us that yield sign. Nitrogen trihydride. So that's one nitrogen. Trihydride, tri means three hydrogens, and it tells us it is a gaseous state. And that's our reaction. Pretty good? Okay. All right, let's try one more. Hit pause and try this one. Common drinking alcohol is ethanol. Ethanol is C2H5OH. And I'm going to make the assumption you know that drinking alcohol is in a liquid state. So these statements often make the assumption that common knowledge is kind of common. People drink liquids. When it is burned, remember burns means reacts with oxygen. Oxygen is O2. How do we know it's an O2? Oxygen is one of the diatomics when it's in its pure state. To produce carbon dioxide. Carbon and di means two oxygens. It doesn't tell us what it is, but you exhale carbon dioxide gas. So that is a gas. And water vapor. So plus H2O, and vapor is another way of saying gas. That is my complete chemical reaction. One more. Okay, hit pause, give this one a go. When solid aluminum reacts with sulfuric acid, which is H2SO4, the products are aqueous aluminum sulfate and hydrogen gas. This one's a little trickier. There's one more thing you got to just double check about. So solid aluminum. Aluminum here on the periodic table, it tells us it's a solid. If you did not know, if it was a metal you were not familiar with, the color, remember, on the periodic table is a big hint as to its state at room temperature. So solid aluminum reacts with sulfuric acid. Remember when we were talking about different things to watch out for when writing chemical equations? Acids and bases typically, and unless you're starting to deal with organic compounds, are going to be aqueous. Typically, they're going to be dissolved in water. So solid aluminum reacts with sulfuric acid. The products are aqueous aluminum sulfate. Now, product, so I got to have a little yield sign. Aqueous aluminum sulfate. Aluminum sulfate, that, I don't know that one, so I'm going to have to bond to make that happen. But this is a metal, and big hint, look, there's the chart of polyatomic ions. So aluminum is group 13, and if you look closely at that on your periodic table, it has a most common ion of +3. Sulfate is an SO4 with a -2, and one positive, one negative. They're going to ionically bond, crisscross. This goes there and that goes there. So I'm going to end up with Al, 2 comes down, SO4, the 3 comes over. And to indicate multiple polyatomics, we put parentheses. So I'm going to put that up here. Do not do your bonding in your chemical reaction. That is just incorrect. And it is aqueous. This tells us aqueous, so that state of matter is AQ plus hydrogen gas. Hydrogen gas is H2 gas. How do we know it is an H2? Again, from our list of diatomics. All right, that will do for this time. We're going to come back and we're going to practice some more of these because writing chemical equations is a skill for anybody taking chemistry.